Hey guys, I'm going to solve example 2329 and 2310 from the book. This is a very comprehensive um, review of the chapter. It has multiple elements. It's a pretty difficult problem. Um, I think if you're able to do this problem and understand it, you can pretty much do anything that he throws at us for the final. So this is a great comprehensive review. However, it is a difficult problem. It is a long problem. So forgive me if this video runs a little bit long. I'll try to speed it up as much as I can. I'm not going to type everything. I have all the answers here. I've solved the problem and it matches the solution that we did in class. So I know all these values should be correct. So I'll just walk through what I did and how to solve this type of problem. The key thing to remember is that what makes this problem so difficult is it has both a variable overhead component and a fixed overhead component weaved into the same problem. So you have to pick out and do the variable component and then the fixed component and take out all the values from this information. It looks intimidating, but if you take it step by step, it's just like everything we've done in class. So let's go ahead and break it down. The first part is very simple. It asks for you to um, compute the standard variable overhead allocation rate and the standard fixed overhead allocation rate. So that's what I did. The first one, I did the variable overhead allocation rate, and that's simply taking the 7,800 here, the static budget overhead, and dividing it by the direct labor hours, and you get $6 per direct labor hour. Same thing for the fixed, except instead of using the variable overhead amount, you move down to the fixed. You divide the fixed 3,900 by the same 1,300 direct labor hours in the static budget, and you get $3 per direct labor hour. Once you have that checked off, you can move on to the next part, and that's where the variable component comes in. So all this data right here, if you want to pause and read it, you can. I'm not going to read all of that because it would take a long time. But basically what I did is I just broke out all of this information and I typed it here so we can see it and refer to it rather than looking back onto this image here. So they just gave us values for the actual variable overhead, the actual fixed overhead, the actual production number of units, actual production direct labor hours, and this is actually computed by taking the 7,000 and multiplying times the direct labor hours, and so that was a computed value that I did on my own. And then the efficiency standard is what they is also given here at 25 direct labor hours per unit. So I just broke all that out. That's not a solution, that's given in the problem, but we need that to solve the variable overhead. So now that we have all of this done, we can start on the variable overhead, and remember we're just doing the same thing: AC, SC, AQ, SQ. The first thing you do is the standard cost, and bang, we already have it up here. So that's given to us. Well, it's not given to us. We calculated it, and luckily we did it correctly, because if you miss that, it will mess up this part, and that's what makes this difficult. Nothing is given. You have to calculate every level. So now we have the standard cost. We need to get the actual cost. The actual cost is the actual amount of the actual variable overhead right here divided by the actual direct labor hours, 1,400 right here. So actual cost divided by the direct labor hours, and that gives us the cost per direct labor hour right there. Actual cost divided by direct labor hour, and we get $7.71. Now there is something unique about this particular piece of data. It did not come out to be an even number. Like most of these numbers are all even with a zero, or they end in a zero. This one terminated in a decimal, a long decimal. So if I moved it to a number format, well, just trust me, it's a weird value. So, but I checked it with what we did in class, and it is correct. So if you're doing this by yourself, don't be alarmed. That's correct. Okay, so now we need to know the actual quantity, um, and that's calculated here. I got that by multiplying the 7,000 units by the standard here, this direct labor hours per unit, to give us how many direct labor hours we used. And then the standard quantity is the efficiency standard here, this 20.25 direct labor hours per unit times the actual number of units, 7,000. So that gives us our breakdown of the AC, SC, AQ, SQ, and from there we can just plug those values in to get the favorable, unfavorable values and amounts. Add those two numbers together to get 300 unfavorable. Okay. All of that is pretty standard, except for this tricky value here. This had to be calculated. This had to be calculated. Now, for me, the really tricky part about this was the flexible overhead values. Okay. The reason why it was very tricky is because in order to get a cost variance, you have to compare actual and budgeted. In order to get a volume variance, you have to compare budgeted and allocated. In this particular problem, the budgeted was the one you had to figure out. So if you don't know the budgeted, you won't be able to get this, and you won't be able to get this. So in previous problems on the test, he gave us the budgeted, and so you were able to get the actual and you got the budgeted, so you could just subtract this, and it's basically 3 columns were given. All you had to do is find this, and you basically had it made. But this one you had to find the budgeted and the allocated. So I'll just walk you through that briefly. For the sake of the video, the actual amount was given, 2,700 here. The budgeted, and I wrote a little note here because this was the tricky part, the budgeted fixed overhead is equal to the predetermined fixed overhead rate, which is all the way back up here, predetermined allocation rate, $3, multiplied times the static budget direct labor hours. And that's given here, static budget direct labor hours at 1,300. And that's how I got this 3,900 value. 3 times 1,300 to get the 3,900. I look back on my notes, that is a correct value. So we can move on. And we also had to calculate the allocated, and that is the same $3, but instead of multiplying it times what we budgeted in the beginning, we have to multiply it times what we actually did, the standard quantity, and so it was 1,750, and that came out to be 5,250. Once you get those, you can subtract these values and then solve as we normally do for any fixed overhead problem. But this is just a little overview of and a solution of how to solve if he happens to interweave a flexible overhead problem with a fixed overhead problem. I don't think he'll do that, but just in case, this video is here as a little breakdown, and you can use it as guidance if you happen to try to review this problem from your notes. Thanks, and good luck on the test.